Here's where a lot of the stuff we've been working on comes together, and it's with this this idea that corresponding parts of congruent triangles are congruent, which essentially means that if you can prove two triangles congruent, you can use the fact that the two triangles are congruent to prove the various parts congruent, which wasn't that helpful before when we had to prove all 6 parts congruent anyway, all the angles, all the sides. But now that we've limited it to SSS, SAS, AAS, so on and so forth, HL, we don't have to prove every part of each triangle congruent. We only have to prove a certain number of parts. But with CPCTC, we can say, okay, well, now the rest are congruent. So let's just look at an example. Let's say we have triangle A, B, C, and triangle D, E, F. And let's say we prove these two, they're both right triangles, and we said, okay, we know that their hypotenuse is equal, and we know that one of the legs is equal. So with CPCTC, CP, corresponding parts of congruent triangles are congruent, we can say that angle C is congruent to angle F without having to write anything else. We can say that angle A is congruent to angle D. We can say that AB is congruent to DE. And all of that is true because of this corresponding parts of congruent triangles are congruent. So what we're going to find is, over the next couple of proofs, it's going to be very easy to prove the triangle's congruent, but then you're going to have to take that one extra step to say, okay, now that I've proven the triangle's congruent, I can then prove this separate part congruent, which I might not have been able to prove prior to this. Okay, here we have a proof. We're told that EG and DF are congruent. We're also told that they are parallel. We're asked to prove that ED is parallel to GF. So I'm just going to mark that in green so I know what I'm going to prove. I'm trying to prove this is parallel to this. Okay. So what I'm going to do is I'm going to start off by by looking for some triangles, seeing if there's any triangles I can prove congruent. Because I've got some pieces here. I've got if I deal with triangle EGD and triangle FDG, I know a couple things. I know, one, that DG and DG are congruent to each other by reflexive property. What else do I know? Well, the parallel helps me, because if I consider DG a transversal, then I can say that angle EGD and angle FDG are congruent by alternate interior. So I've got, we'll call it angle G is congruent to angle D for the purposes of just shorthand, and that's alternate interior. So now I've got side EG, angle G, side DG. I've got these two triangles congruent now by side, angle, side, because it's the included angle that I have congruent. And that helps me, because then I can say that angle, let me use yellow here just to indicate, angle EDG, this one here, is congruent to angle DGF, and that's because they're corresponding parts of congruent triangles. So I'm going to, just for short term in yellow, I'm going to write angle G, the yellow angle G, is congruent to yellow angle D in this case, and that's by the CPCTC, right? Because they're corresponding parts of congruent triangles. If that's true, then I can get to my final statement, which is that GF is parallel to ED, and that's by the converse of alt interior angles. So I sort of went through the logic quickly. Let me take a moment on the next slide and show you what the proof would actually look like. Okay, here we are at the beginning again of the proof, and in this time you can see that I've got the given still there, and I've got what I want to prove still in green. Okay, I've set up my statements and my reasons. I'm going to start off with the given, e.g., I can probably just do it like this, e.g. parallel to df, e.g. equals congruent to df, and those are both given. Okay. Now I'm going to look at these two triangles I've got here, and I'm going to say, okay, I want to prove triangle. Well, let me prove the parts first. So I know that DG is going to be congruent to DG, and that's reflexive property. I also know that angle EGD is congruent to angle FDG because of those two parallel lines we have, and that being a traversal. Those are alternate interior of each other. Now I can say triangle EGD is congruent to triangle FDG, and that's because I've proven I have two sides. One's in the given, one I proved by reflexive, and the included angle, so that's side, angle, side. Now I can say that angle, I'm looking for that other side of D now, so I'm looking for EDG is congruent to angle, now the other one, right? Let's see, EDG and FGD, and that's because corresponding parts of congruent triangles are congruent. Finally, I can say that GF is parallel to ED, and that's by the converse of the alternate interior angle theorem. Okay, so there's a quick proof to show you how CPCTC can come into play to give us two angles that we needed but we couldn't have found if we didn't prove those triangles congruent first.